Let us have a look at how NICA works. The process of preparing a beam for the experiment starts in a device called the heavy ion source. It is a superconducting solenoid with a field of 6 Tesla, in which atoms of gold sputtered onto a tungsten wire evaporate at a temperature of about 1000 degrees, and afterwards are ionized by an electron beam, picked up, and accelerated to a certain energy to be transferred to the linear accelerator. In the linear accelerator, by means of the beam transport and focusing system, heavy ions are accelerated to about 3 million electron volts and transferred further along the transport channel to the first cascade of accelerators called the booster. The booster is a superconducting ring with a perimeter of 211 meters, in which a beam is prepared for the experiment for about 2 seconds and then transferred to the following NICA cascade. In the process of acceleration, the beam, or the bunch of ions, acquires an energy of approximately 500 million electron volts, cooling to the required size. When we talk about beam cooling, we do not mean energy decrease or deceleration. We mean bringing the cross and longitudinal dimensions of the beam to the minimum parameters, those required by the experiment. After accelerating in the booster, the bunch is transferred to the next ring called the nucleotron. The nucleotron is a superconducting accelerator. By the way, it was one of the first superconducting accelerators of heavy ions in Europe, and it was launched here in Dubna using our technologies. In the nucleotron, the bunch is accelerated to several billion electron volts, and afterwards, the prepared bunch, with an energy of several billion electron volts, gets into one of the collider rings. The entire procedure of bunch preparation takes about 4 seconds. We need to make several, as we call them, injections of bunches into the first and the second collider ring. In total, there are about 50 injections or procedures of preparation and acceleration of bunches for the experiment, and the whole process takes about 4 to 5 minutes. After we have filled the collider with the right amount of gold ions, the so-called beam gymnastics begins in the collider. Gymnastics means that we should prepare a beam for the experiment within a very short period of time if we want to have the maximum number of useful events at the point where the beams meet and interact. And this is how the statistics and effectiveness of the experiment are estimated. We need to squeeze the beams to the minimum size so that they could have the maximum ion density in the bunch. Only in this case will we reach the necessary density of nuclear matter and the necessary results that we expect from the experiment. The dimensions of bunches characteristic of the experiment are as follows. Bunch length about 60 centimeters, and cross dimensions about 1 millimeter vertical and horizontal. And now the beams collide in a specially prepared section called the meeting section or beam interaction point. And it is at this point that the main device, the main experimental detector of the entire accelerator complex, is located. In our case, this detector is called MPD, which stands for Multi-Purpose Detector, or Detector for Searching and Studying the Mixed Phase of Nuclear Matter. The detector is an enormous cylinder. If you imagine a fuselage of a large, long-haul aircraft, for example, Boeing Jumbo, then you will get the idea of the real size of the detector. The length of this cylinder is about 10 meters, and its diameter is about 7.5 meters. And it is inside this detector, in the very center, that the collision of two bunches or beams occur, and billions of particles born in gold ion collisions fly in all directions. Therefore, the main technological or engineering task of our complex is that at the right time and at the right place, we must collide bunches of heavy particles of immense intensity. And the main physics task, the main scientific task, is that from 1 billion interactions that the detector will register, we must find and distinguish those very rare events, those particles that will indicate that a phase transition has taken place in the observed system, or a mixed phase state of nuclear matter manifested itself. And thus, we will be able to state that in our experiment at the NICA collider, we have observed that earliest universe.